Hello, this is Mr. Stansbury. I'm going to take you through the notes on operations with complex numbers. At the end of this, you should be able to say, I can identify, add, subtract, and multiply complex numbers, and I can explain the properties used to operate with complex numbers. Okay, so let's get into what we're talking about here. So, real numbers are numbers that we can place on the number line, like 7, negative 4.2, pi, square root 11. Pretty much everything that we know up until this point is a real number. Now, what we just talked about in the last section was imaginary numbers, and that's the square roots of negative numbers. So 2i, square root of negative 5, negative 7i, square root of negative 9. All of these are imaginary numbers. Okay. Now, complex numbers, which is what our title is up here, is a combination of real and imaginary numbers together. So 4 minus I would be a complex number because it's got real number and an imaginary number together. So negative 3 plus I root 2, 6 minus 2/3 I, so forth and so on. So what we're going to do is we're going to figure out how to add, subtract, multiply, and divide with these with complex numbers. Okay. So first thing, identify what type of number each expression is. So negative 4i it does have a real number and an I, but it's just considered an imaginary number. So let's just say I for imaginary. 2 minus 3i, it's got a real number and an imaginary number, because like this here is the real number. If it's got addition or subtraction, that means now we have to look at the two different parts, whereas this doesn't have subtraction, so just negative 4i, just imaginary. 2 is real, negative 3i is imaginary, so that makes this a complex number. Okay, 4 pi is just simply a real number. 0 is also a real number. We've known about all these things here before. And then I squared. This is where I'm going to try to trick you, because I, if you'll remember, I equals the square root of negative 1. So we can put square root negative 1 in here and square it. So if we take the square root and the square are going to simply cancel each other out, and we get negative 1, which is indeed a real number. So I squared, so we know that I is the square root of negative 1. We also know now that I squared equals negative 1. And that's another big thing that you're going to use with imaginary numbers. Anytime you get an I and it's squared, simply negative 1. Okay? Now what we're going to do is we are going to simplify the expression. So we have negative 3 plus 5i plus 7 minus I. So since we're simply adding this to this over here, we're just going to combine the real numbers, the negative 3 and 7. That gives us 4. And then let's do this. We're going to also combine the imaginary numbers. So we've got 5i and negative I. Combine those two together. 5i minus 1i is 4i. So we simply get 4 plus 4i is what that is going to equal. Okay. Now with this one here, 6 minus 2i minus negative 3 plus 7i, these are both being subtracted. So what I would do if I were you is I'm going to distribute this negative through first to both of these. And so we really have 6 minus 2i, negative 3 is plus 3. And negative and positive is negative 7i. Okay, and we really don't need these parentheses here anymore. And now all we're going to do is simply collect like terms, right? 6 and 3 group together to get us 9, and then negative 2i and negative 7i, those group together to give us minus 9i. Now it is a coincidence that these two, 4 and 4i, 9 and negative 9i, it's just a coincidence that those match. They're not going to always match. It just kind of so happened in this this set of examples here. Okay? Okay, next we're going to look at multiplying complex numbers, but before we do that, let's take a quick little comedy break.
Good doctor, I think. I told him I get heartburn sometimes, so he goes and gets me a list of things that cause heartburn. I'm looking at the list and I'm like, I already know this. I know how to get it. That's like going into the hospital with a cannonball wound and they show you a list. Here's how you get cannonball wounds. I have a cannonball wound. It's gaping. Do you have a tube of cannonball wound ointment? Number one, do not stand directly in front of a cannon. How true that is.
All right. So multiplying complex numbers. So example 3, simplify these expressions. So we're going to multiply these out. And there's a couple different ways to multiply polynomials. You may have seen the FOIL method. So first I'll show you the FOIL, which is first, outside, inside, and last. Or some people might have shown you like the hawk, bill, or whatever. So anyway, FOIL stands for first. So we're going to do 5 times -2. So 5 times -2 is -10. O is outside. So now we're going to do 5 times I. So that's 5I. I is inside. So -3I times -2. So the negatives cancel out. 3 times 2 is 6. And we still have an I there. So that's 6I. And then L for last is -3I times +1I, right? So negative times a positive is a negative. 3 times 1 is 3. And then we get I times I, which is officially I squared, right? Now, we just learned that I squared is the same thing as -1. So that's really -3 times -1, which is just +3. So now, to simplify this, we're going to take the -10 and the 3 together, and that's -7. And then the 5I and the 6I is plus 11I. So that is multiplying these two together here using FOIL. Okay. Now, another way you can do it is you can take one of these two and stack it on top of the other, and you just like you did like long division or long multiplication. So I'm just going to move this one underneath. So I'm going to do -1 minus 3I. You can do whichever way you want. I won't ever tell you if you've got one way that works for you. I will never tell you you have to do it a different way. So this here, now this is gone here, right? So we're just going to do -3 times -5 is 15. I times I is I squared, right? -3 times 7 is -21. And then we have an I there to patch on there. And then we usually put a little 0 in here to hold the place, right? -1 times -5 is negative times negative is positive. And then 1 times 5 is 5. And then we have an I there, right? And then we do -1 times 7 is -7. And now we're going to simply add these all together. That's -7. -21I and 5I is -16I. And then 15I squared is going to, that's the same thing as 15 times -1. So that's really just -15. So there's -15 there. And now we will add these two real numbers together. And that gives us what? -22. And then we still have the -16I. So that is how we multiply complex numbers. Okay? All right, last thing we're going to do is divide complex numbers. So we're going to simplify these expressions here. So if you remember, we can't have any square roots in the denominator, and really I is the square root of -1. So we have to get rid of this from down there. So what you want to do in order to get rid of your imaginary numbers down here in the denominator, which we can't have, is we're going to do what we call multiply by the conjugate. Okay, so what that is we're going to ignore the top, and we're just going to look at the bottom, because the top we don't care about. We can have whatever we want up here. We just can't have i's and square roots in the denominator. So we're going to take -2, and then the conjugate means we're going to switch this sign, whatever it is here in the middle. So that's going to be -2 minus 3i. And we're going to multiply the top and bottom by the same thing. So if we're going to multiply the bottom by negative 2 minus 3i, we're going to multiply the top by negative 2 minus 3i as well. So now it's just two different multiplication problems here, right? So let's do this. We're going to do 7 minus I, and then we're going to multiply that by, we'll do the little FOIL method for you. I think most people are probably familiar with that, so we'll do that, 2 minus 3i. But if you want to do it with the stack method, that's totally fine as well. So let's FOIL that out. First outside, inside, last. 7 times negative 2, negative 14. 7 times negative 3 is negative 21, but we've got an I with it. Negative times a negative is positive. That's a 1i. 1 times 2 is 2. Then there's an I there as well. And then negative times a negative is a positive. 1 times 3 is 3. And we've got I squared, right? Which we now know that that is 3 times negative 1, which is negative 3. So that means the top is going to be negative 14 and negative 3 is negative 17. Negative 2i, oh, look at that. Negative 2i and positive 2i. Oh, oops, I did. Hold on a second here. Okay, I see what I did. I did the inside, and then I messed up the outside one. So the outside, oh, yeah, sorry. Negative, I just saw the negative 2. I forgot, I didn't see the 1. So negative 21 and 2 is going to be negative 19i. There we go. That's what it's supposed to be. Now we're in business. Okay, now that's just the top. So now we got to do the same thing with the bottom. So we've got negative 2 plus 3i times negative 2 minus 3i. Okay, so first outside, inside, last. Negative 2 times negative 2 is 4. Negative 2 times negative 3i is positive 6i. 3i and negative 2 is negative 6i. And then 3i times negative 3i is negative 9i squared, which is really negative 9 times negative 1, which is positive 9. Okay, and now here's the great part. In the denominator, these two are always going to cross out. They're always going to equal 0, right? So really in the bottom we have 4 plus 9 is 13. So here is our final answer for that. Okay? All right, if you get that, perfect. You can probably stop here and then start working on some problems with this. But I'm going to show you one more just in case if this is tricky for you, so that just so you have another example. So I'll do this one a little bit faster, but here we go with this one. So we're going to multiply by the conjugate, top and bottom, right? So if it's 6 minus I on the bottom, it's going to be 6 plus I and 6 plus I. So in the numerator, we got negative 2 plus 3i times, you know what? To go a little faster, I'm going to do the stack method here, 6 plus I. So 3i times I is 3i squared. I times negative 2 is negative 2i. Put 0 to hold the spot. 6 times 3i is 18i. And 6 times negative 2 is negative 12, right? So when we add these together, I'll make a little thing here so we can figure out what's going on there. 3i squared is really just negative 3, right? So that is negative 3 and negative 12 is negative 15. And then negative 2i and 18i is plus 16i. So that's what we get for the top, is negative 15 plus 16i. And in the denominator, we're going to get 6 minus I times 6 plus I. All right, I times negative I is negative I squared. I times 6 is 6i. 0 in there to hold the spot. 6 times negative I is negative 6i. 6 times 6 is 36, right? Negative I squared is negative 1 times negative 1, right? Because that's negative 1. I squared is negative 1, so that's really just 1. So 36 plus 1 is 37. And then the 6i and the negative 6i turn into 0. So on the bottom, we just have 37. And there's our answer there. Okay? All right. If you have any further questions on any of this, please feel free to ask in class. Thanks.